So in this video we're going to be going over configuring Flexchain with SOPAS engineering tool. The wiring of it, we'll just start with that. So this cable goes directly to power or my IO-Link master, so this is the IO-Link variant. I've got the USB here, that is for communication of my PLC. And then coming out of port A, this is port A. I'm coming into this first sensor, which is through beam sensor. The mate to it is over here, which is on the other port. And I've got a background suppression sensor here. I've got a retroreflective here, the other side of my through beam, and another BGS here. So on port A is coming directly from the host, coming here, coming out of the first sensor or the first guest to the second one, coming out of it. And I'm coming to the receiver. So this is on port A. On port B, I'm doing the exact same thing. I'm coming into the retro, coming in the other side of the through beam, coming to a BGS, and I'm coming to the sender. So one thing you have to be conscious of is how you lay out the chain or the ports. If you have, say, emitter and receiver, they must be on opposite ports. They cannot be on the same port. So what we'll do first is we'll just power up the device. Well, there's one other thing I've got at the end of the SLG, since it's the last one or the last host in the chain. I've got these terminal resistors or bus terminals on the end of each one of them. So go ahead and power this up. You'll see that I've got a few alarms coming here. Now what we could do is I can go ahead and pick this up, and I could auto assign these with the buttons by holding the menu button down, and then once I get here, you'll see on the top there's a teach and there's an auto assign as well. We're going to do this with SOPAS, but you could do some of this on the device itself. So what we'll do is come here and we'll let SOPAS scan for all of the SIC devices that it sees, either on my IO-Link network that I've got plugged in with SI-Link box or over Ethernet. And SOPAS engineering tool is a free software that you can get off of stick.com. There's no login or purchase necessary. You just go directly on the website and download it. So I'll get two different ones here. I'll get the COM4, which will come off my SI-Link box, that is my IO-Link communication. I've got the USB. You'll want to pull this USB when you're using SOPAS. So once it loads, we'll double click on the icon itself. There is no login for this for what we're trying to do. Now all of my devices are up. You can see that I've got errors, I've got chain changed, I've got a lot of different things going on here. So we can go through different pages and go to teach position, and right now it really doesn't know everything that's going on. It's still got some errors. Got logic. So first let's come to just teach position. So what we can do is just do an auto assign, and if it does automatic position, it'll do, if I do auto assign, it'll do automatic position assign, confirm change, and it'll automatically assign my zones. So if I want to do that, then I can just reconfigure it since it's a brand new chain. Now it sees everything here, but I still need to teach all of my guests. So I can teach my guests. And now you can see that all of my status alarms have gone away. If I wanted to expand this, now I can get individual beam status from each one of these guests. So that's what we talked about in the other video, was the different channels and the different guests. Okay, I've got the SLG, which is guest 2, right? Then I've got a retro reflective here. And I've got my through beam here. Then I've got two BGSs, right? So it depends on where they fall on the chain. Now if I didn't like where that fell on the chain, I can automatically assign these or move these around. Now please note that when you do, it's going to change your process data. So right now I've got channel 1 through 8. So you can see that each individual beam or each individual channel is going to have its own output status. So if I change the position of the channels. So right now, if we look at guess 2, is channel 2 through 9. So right now, if I come to channel 2 through 9 on my process data, now we should see that start to come through channel 2 through 9. So if I move that to a different position, and I move it up, or let's just see if we can move it down, now it's going to be 5 through 12. So if you move the device in your zones, it will move where the data is going to go. So I've got teach positions. With this will tell me all the different firmware that I have on each device. If I come to the host, I can look at the firmware that I've got here. This is very critical depending on what components you're using. The teach-in zones. So unlike other devices where we have a number of block beams or last block beam, this goes off of channels. So number of channels blocked, last channel blocked, first channel blocked. So number of channels blocked is good to know that something is in there, and possibly the full size of it when everything's broken. But I can also do that with the last channel block and the first channel block. So let's just say if I wanted a discrete I/O signal, just if 1 through 4 was blocked, if any of those, then I can come here. If I can move this over, I can come here to number of channels blocked, and I want to compare that against 1. But I just want to do 1 through 4. I don't want to do 1 through 12 like it was already on. So now if I do anything 1 through 4, then I get a high signal. But if I go and I block, say, channel 5 and starts on SOG, the signal still stays low. If I wanted another channel or another zone or QInt to go high, when, say, 5 through 12 was blocked, then I could just click on the second one, do 5 through 12, and we can do the same thing. Another channel blocked, and now we get that same signal here for 5 through 12. So now I have 2 different zones, and I'm getting 2 different outputs depending on what zone is blocked. We can also do different logic in here as well. If I wanted to do QInt 1 or QInt 2, then I can do that in here as well to give a high signal. So if I wanted to, say, tie those together, that is a way that I could do that. So now I have an OR gate. So if anything is blocked at this point, then I get a high signal. The pins can also be configured for outputs if you so wish. I can do triggers over pin 2 as well. So it just depends on what we're trying to set up inside of the device. These are also user configurable. You can go back to the default settings. Or if I want to just have certain data coming, then I can change all this as well. So it's all user configurable. One thing to verify is if you're changing one of these out, that you get a backup from this, because if all of this has been set up and there's no way for the PLC to rewrite it, or the master is not set up to rewrite the host, then you will have to reconfigure all this unless you save a backup via SOPAS engineering tool. And that can be done here with the export function. So you export this file and you import the new one, and that will save the data. Factory reset is on the last page. Now if we want to do beam blocking, we can do that as well. So that's just a quick overview of the Flexchain host and the software via SOPAS engineering tool, and the different things that you can do inside of it. We can do measurement, or if you just want to do large and OR gates. But it's a way that we can connect up to 60 sensors or even more with a Flexchain booster and get individual signals out of each sensor without running 60 different cables.